सो हेलो नमस्कार टू द ऑल केमिस्ट्री लवर्स, डॉक्टर्स एंड इंजीनियर्स ऑफ द नियर फ्यूचर। मैं विजय कुमार सोनी आपका हार्दिक स्वागत करता हूं इन केमिस्ट्री वाला चैनल रिगार्डिंग टू योर वन एंड ओनली केमिस्ट्री। In previous video we have discussed about the just process of electrolysis and just which kind of the compound will be formed over the different electrodes as a cathode and anode. मीन्स पर्टिकुलर कैथोड एनोड पर किस कंपाउंड का डिप्लीशन होगा उसके बारे में भी हम पढ़ चुके हैं, जो कि बोर्ड एग्जामिनेशन के पॉइंट ऑफ व्यू से इंपॉर्टेंट है। Now the time to discuss about the very important topic, that is the just laws of Faraday, means Faraday's laws of electrolysis. So these are regarding to the electrolysis. Faraday's laws of electrolysis. If we'll go with just Faraday's law of electrolysis, then there are just two important laws regarding to the electrolysis. So Faraday proposed it's a quantitative relationship. It's a quantitative relationship regarding to the formation of different substance over different electrodes. What is that? There are just two laws. First is your first law of Faraday. This is the first law of Faraday, and this is second law of Faraday. Second law of Faraday. There are two laws. If we'll go with the first law, it's very important. First law of Faraday. What is that? This is regarding to just one electrolyte. Suppose you have any of electrolyte over here. Suppose this is the electrolyte and this is the electrolytic cell. In electrolytic cell, as we all know, because we have discussed in previous video, as we all know, this is the electrolytic cell in which cathode will be as a negative terminal and anode will be as a positive terminal. This is the cathode and this is the anode, and this is your electrolyte. If according to this law, first law of Faraday, suppose we are going to flow Q coulombic current, just then here will depletion of the substance over the cathode and anode different substance, and if the amount of the different substance is your capital W gram, then we can say the deposited amount of the substance will be directly proportional to the just we can say value of the current, quantity of the current. So what we can say that just according to first law of Faraday, this is the first law of Faraday. So according to this law, just amount of substance depleted over different electrodes will be directly proportional to just we can say depleted amount of the just according to this law, amount of the substance depleted over different electrodes will be directly proportional to the quantity of, just we can say amount of the current. This is the first law of Faraday. What is that? As we have discussed, just the depleted amount of substance is W and the value of current is Q coulombic current. So what we can say that W is proportional to the Q, and for the removal of just proportionality constant, we can use W is equals to ZQ. This is the first law of Faraday. If we go with the just meaning of Z, then here Z is your electrochemical constant. This is the electrochemical constant. If we'll go with the further, then as we all know, current I is equals to will be just Q upon T, and Q is equals to it will be I cross T. I cross T. Then we'll keep the value of Q over here. Then this is your equation number second. So equation first will be, what will be? This is the W is equals to ZQ, so Q is equals to I cross T. Then it will be W is equals to Z into I into T. This is the another form of Faraday law. These are the three equations. This is the first equation regarding to Faraday law, and these are the just for the second equation regarding to Faraday law. If we want to get just definition of the electrochemical constant, then we can take if I is equals to 1 ampere and T is equals to 1 second, then here will W is equals to Z, or you can say Z is equals to W. So what is the meaning of just electrochemical constant? We can say that electrochemical constant is equal to the amount of substance in gram. Just electrochemical constant is equal to the amount of the substance depleted. This is the depleted over different electrodes. Depleted over different electrodes. So electrochemical constant is equal to the amount of the substance depleted over different electrodes when 1 ampere current is flowing for 1 second through it. कि पर्टिकुलर किसी भी इलेक्ट्रोलाइटिक सॉल्यूशन में आपने 1 एम्पियर का करंट 1 सेकंड के लिए फ्लो किया, then I is equals to 1 ampere, T is equals to 1 second, then W is equals to W is your amount of different substance depleted over different electrodes, and Z is the electrochemical constant. So it will equal to the depleted amount of the substance over different electrodes when there is 1 ampere current is flowing for 1 second. This was about the first law of Faraday. Go through with the just properly with this kind of the law. It's too important because of it will be a lot of question regarding to Faraday law, not only in different kinds of the home examinations, but also in different kinds of the board example also, and it is also important for the just competition exam. So be in game. So now I would like to go with the second law of Faraday. This is the second law of Faraday. What is that? Listen me carefully. And we'll use again first law of Faraday regarding to this. And it is too important. What is that? Listen me carefully. Because of now the time to do study properly. So take it seriously. Take the each and every video very seriously. Because of solution, CK, and electrochemistry. These are the two important chapters. So this is the second law of Faraday. This is the second law of Faraday. What is that? Suppose there are two electrolytes. This one is the first container and this is the second container having different electrolytes. Suppose first electrolyte exists CuSO4 solution. You can take another is your AgNO3 and both are connected serial in serial combination like this, plus and minus. These are the two electrodes as you can say plus and minus. Here's the you can say CuSO4 solution, or you can take AgNO3 solution, one of the AgNO3 solution, and here you can take just CuSO4 solution. There are just two different electrolytes. So according to this law, what will be? When there is same value of current is flowing through different electrolytes when there is same value of current flowing for same time from different electrolytes, then depleted amount of substance, that is in gram, will equal to either electrochemical constant, or you can say their equivalent mass. This is the most important thing कि पर्टिकुलर आपने दो इलेक्ट्रोड से टू जस्ट इलेक्ट्रोलाइटिक सॉल्यूशन से आपने सेम वैल्यू ऑफ करंट सेम टाइम के लिए फ्लो किया, तो डिफरेंट इलेक्ट्रोड्स में डिप्लीटेड अमाउंट ऑफ द सब्सटेंस will equal to the electrochemical constant Z, or just will equal to the equivalent mass of them, means जो भी कंपाउंड यहाँ पे डिप्लीट हो रहा है उसके इक्विवेलेंट मास के इक्वल होगा. इस बात को प्रूव करने के लिए just as we know that what is that Faraday, first law of Faraday, that is the W is equals to ZQ. Z is the electrochemical constant and we all know Q is equals to I cross T. So the form of this formula will be W is equals to Z into I into T. This is the equation first regarding to the second law of Faraday. If we'll go with the first electrolyte, so this is the first electrolyte, it will be W1 is equals to Z1 into I into T. I and T both are constant because of, according to this law, just same value of current for the same time. Time is same, so constant, and I, current, is also constant. For second electrolyte, what will be? It will be W2 is equals to Z2 into I cross T. This is the equation number, you can say third. So from equation second and third, what will be? It will be W1 upon W2 is equals to Z1 into I into T. upon Z2 into I into T. From T to T remains cancel, I to I cancel. So W1 upon W2 is equals to Z1 upon Z2. From this equation, it will be W is equals to Z. This is the most important. Now the time to discuss about the value of Z. If you go with the value of electrochemical constant, then it is equivalent mass upon 96500. This is the value of charge regarding to just it is also called as 96500. Coulomb is called as 1 Faraday, or you can say 1 mole electron. 1 mole electron. So if we keep the value, then W1 upon W2 is equals to, this is the Z1 upon Z2. This is the value of Z1 E1 upon 96500. Value of Z2 is your E2 upon 96500. Both remains cancelled. So this will be W1 upon W2 is equals to Z1 upon Z2 is equals to E1 upon E2, equivalent mass of substance first and equivalent mass of the substance second. This is the second law of Faraday, equation number 5th. From this equation we can say W is equals to Z is equals to E. This was regarding to second law of Faraday. And go through with this topic properly, with this slide properly. As I told you, these two laws are very important because of without doing these, it is not possible to do a lot of numerical. So be in game because of I always with you, and I am giving you a lot of matter. And now we have a lot of videos regarding to different chapters as a coordination chemistry, as a solution, as a just haloalkane, halary, and we'll go with the further also as alcohol, phenol, ether, aldehyde, ketone, carboxylic acid, so on. Before your examination, I'll upload each and every topic of the board examination. So if I go with the just question regarding to just Faraday law, then first of all it is necessary to know about the value of just Faraday constant and what is the meaning of 1 Faraday. So listen me carefully. This is very important. So now I would like to go with the just 1 Faraday. अगर बात करें तो हम पहले कैलकुलेशन में किसी भी रिएक्शन के लिए हम लोग काम में लेते थे इलेक्ट्रॉन्स को कि इस रिएक्शन के लिए इतने इलेक्ट्रॉन रिक्वायर होंगे, इसके डिप्लीशन के लिए, इसके रिडक्शन के लिए. बट नाउअडेज इट विल बी यूज ऑफ मोल कंसेप्ट. It will use of just mole electron. So listen me carefully. This is the knot. Here will use of mole concept. Mole concept regarding to the charge means 1 mole electron is equals to 1.6 into 10 to the power minus 19 coulomb, and this is the 6.022 into 10 to the power 23 as a Avogadro number. If I multiply them, then the value will be your 96487. This is the 96487 coulomb per mole. Nowadays, as a round figure, we can use 96500 coulomb per mole as a, you can say, 1 mole of electron. Now the time to discuss about the questions. So calculate total value of charge for following. The first question is you can take Na plus changes in Na. This is the second question. Mg plus 2 changes in Mg. This is the third question. Al plus 3 changes in Al. This is the fourth question. MnO4 minus changes in Mn plus 2. This is the fifth question. MnO4 minus changes in MnO2. This is the sixth question. Cr2O7 2 minus changes in Cr plus 3. These are the important questions. If I'll go with the first question, this is the solution first. Solution first. Here's the reaction. Na plus changes in Na. When I'll balance the reaction, then on the left side it is plus 1 charge, on the right side it is 0. So regarding to the balancing of electron, here will use of 1 electron. This is the Na. So I'll say for this reaction, here will require 1 mole electron. Yeah, you can say 1 Faraday. 1 Faraday, because of 96500 is also equal to the 1 Faraday. And if anybody asks you how much value of the charge will be, then you can say 1 Faraday is equals to, this is the 96500 Coulomb, total value of the charge. It's too simple. Regarding to second question, what is that? This is the Mg plus 2. This is the changes in Mg. Here is plus 2 charge, here is 0. So Mg plus 2, 2 of electron changes in Mg by the balancing of the reaction by ion electron method. So here will require, just we can say 2 mole electron. 2 mole electron means you can say 2 Faraday, or 2 Faraday means total value of charge 2 into 96500 Coulomb. So the value of charge will be 00. 2 5s are 10, 2 6s are 12, and 1 13, and this is the 2 9s are 18. If I go with the calculation, 2 5s are 10, this is the 2 5s are 10, 2 6s are 12, and 1 3 13, 2 9s are 18, and 1 19. 19. 5 2s are 10, just 16, 6 2s are 12, 13, and 9 2 18, plus 1 19 Coulomb. This is the total value of the charge. Now the time to discuss about the third question. This is the Al plus 3, changes in Al. Here will requirement of just 3 electron. So we can say here will require as a 3 mole electron. 3 mole electron means 3 Faraday charge, as a 3 into 96500 Coulomb. So this is the 00. 3 5s are 15, 3 6s are 18, plus 1 19, and 3 9s are 27. This is the 3 5s are 15, 1 3 6s are 18, 1 19, and 3 9s are 27, and 1 28. This will be the total value of charge for the question number 3rd. We'll go with the just question number 4, 5, 6. Go through with the entire matter because it's too important. Go through properly. Because of it's time to discuss about the question number 4, 5, and 6. Both 3 questions are very important. So what are they? Listen me carefully. So question number 4 is your, regarding to this question number 4, remember one thing, this is the per magnet ion, and always changes in Mn plus 2 in acidic medium. ये हमेशा के लिए आपको याद रखना है. कि पोटेशियम परमैग्नेट का परमैग्नेट आयन एसिडिक मीडियम में ऑलवेज Mn+2 में चेंज होगा। आयन इलेक्ट्रॉन मेथड से आपको इसको रिएक्शन को बैलेंस करना है। इफ यू फॉरगॉट, अगर आप भूल चुके हैं तो सबसे पहले आपको क्या करना है, मेन एलिमेंट को बैलेंस करना है, मेन एलिमेंट। आफ्टर देन यू विल गो विद द जस्ट बैलेंसिंग ऑफ ऑक्सीजन। ऑक्सीजन को बैलेंस करने के लिए आपको वाटर मॉलिक्यूल यूज करना है। आफ्टर देन यू विल गो विद द जस्ट हाइड्रोजन। हाइड्रोजन के लिए आपको H+ आयन यूज करना है। एंड फॉर द चार्ज इट विल बी यूज ऑफ इलेक्ट्रॉन, but this is for in acidic medium. So first of all, I would like to go with the just MnO4 minus, changes in Mn+2. Mn is balance, +2 is the charge. So don't go with the charge. First of all, you have to go with the just stoichiometry, Mn1, Mn1. Now the time to discuss about the oxygen. For the balancing of oxygen, it will use of water molecule. So this is the MnO4 minus, changes in Mn+2, and here will use of 4 of H2 as a water molecule. Now balancing of hydrogen, it is 4 to the 8 hydrogen, so here will use of MnO4 minus, this is the 8 of H+, changes in Mn+2, and this is the 4 of H2O. Now everything is balanced except this charge. Charge is your -1, here is the +8, so difference of +7, here is the +2 only. This is the molecule, so its charge will be 0. So on left side it is 7 electron, on right side it is 2 electron, and this is the reduction reaction because of its, here is the removal of oxygen. So we can say this is the reduction process. Reduction process. So for the balancing of charge, it will use of electron over the left side for the reduction reaction. How much electron? Here will require 5 electron. So that's why here will MnO4 minus plus 8 of H plus. This is the 5 of electron, changes in Mn+2, and this is the 4 of H2O. This is the entire part as a balancing of reaction. If we'll go with this balancing of reaction, then here 5 mole electrons are required. These are as follows. So 5 mole electron, you can say just 5 Faraday, you can say 5 into 96500, total value of charge 96500. This is the 00, 25, 5 as a 25, 32, 3 and 48. This will be the total value of the charge regarding to the this MnO4 changes in Mn+2. Now I would like to go with the next question. This is the 5th question. MnO4 minus, changes in MnO2. For this, the medium will be your basic. Because of acidic medium में Mn+2 में चेंज होगा कि MnO4, और बेसिक मीडियम में MnO2 में चेंज होता है, ये आपको लर्न रखना है. Now everything is simple. First of all, you will go with the main element. So this is the balance. Further oxygen on the left side 4 oxygen, right side 2 oxygen. So over the right side it will use of 2 water molecule for the balancing of oxygen. This is the MnO2 plus 2 of H2. Now the time to balance the just hydrogen, 2 2s are 4. So here will use of MnO4 minus 4 of H plus gives you MnO2 plus 2 of H2O. This was about the balancing of hydrogen. If we'll go with the just basic medium, so it's slight change. बेसिक मीडियम में आपने जितना H प्लस यूज किया है उतना OH माइनस दोनों तरफ यूज करना है, इन बोथ साइड. सो यहाँ पर्टिकुलर 4H यूज करें, 4OH दोनों तरफ यूज करना है. So this is the MnO4 minus, this is the 4 of H plus, and this is the 4 of OH minus, this is the MnO2, this is the 2 of H2O, and this is your 4 of OH minus. Here these two remains as a water molecule. So MnO4 minus plus 4 of H2O gives you MnO2 plus 2 of H2O plus 4 of OH minus. These remains cancelled. Here will 2 of H2O. So you can say MnO4 minus just 2 of S2O. Here is the 2 of S2O, and if we'll go with the charge 2 of S2O, here is the changes in MnO2 plus 4 of OH minus. राइट साइड में आपके पास में -4 आ रहा है, लेफ्ट हैंड साइड में आपके पास में -1 आ रहा है. So here will require only 3 electron on the left side. So the balance reaction is your MnO4 minus plus 2 of S2O plus 3 of electron changes in MnO2, and this is your 4OH minus. So for this change it will require 3 mole of the electron, and this is the balance equation. And how much charge will require? We'll go with the just next video. Go through properly. This is very important topic because of without doing, as I told you, it will be a lot of questions here. So go through easily. So if we'll go with this question, then here is the 3 mole electrons are required. So I'll say, what is that? Listen me carefully. So this is the just your, you can say 3 mole of electron are required. 3 moles of electron. 3 mole of electron means 3 Faraday, means 3 into 96500. This will be your 00. 3 5s are 15. 3 5s are 15. 3 6 are 18 plus 1 19, and 3 9s are 27 and 28. This will be the total value of charge 289. This is the 500 coulomb. Now the time to discuss about the final question, question number 6, and this is the Cr2O7 2 minus. It is also called as dichromate ion, which we can get by potassium dichromate, and always Cr2O7 2 minus in acidic medium changes in Cr plus 3. Remember one thing, ये आपको मैंने कहा ना लर्न करना पड़ेगा, acidic medium. Now the time to discuss about the balancing of reaction. Chromium is not balanced, so Cr2O7 2 minus. Here we'll use of 2 of Cr plus 3. This is the Cr2O7 2 minus. Now the balancing of oxygen. Now अब आप जान चुके हैं particular कि it's easy. So for the balancing of 7 oxygen, it will use of 7s2O. Cr2O7 2 minus. 7 2s are 14H plus, and this is the 2Cr plus 3. This is your 7s2. Need not to balance by the just OH minus because of its acidic medium. So if we'll go with the charge, then -2. This is the plus 14, difference of plus 12. Here is the 0, and here is the plus 6. So on left side it will requirement of the 6 electron. So what is that? Cr2 O7 2 minus 14H plus. This is the 6 electron changes in 2Cr plus 3 plus 7 of S2O. 6 mole electron are required, means we can say just 6 Faraday. Here is 3 Faraday are required, and 6 Faraday means 6 into 96500 coulomb. So total charge is 00. 6 5s are 30, 6 6s are 36, 39, and 6 9s are 54, and 3 57. Let me see. Just 6 5s are 30, 0 3, 6 6s are 36, 9 39, 3 6 9s are 54, and 3 just 57 coulomb charge. So this was about the just Faraday law, and with the important questions. Go through easily, seriously with this matter. So the doctors of the near future and the engineers and all the chemistry lovers, take it seriously because this chapter is very important. बिकॉज ऑफ केमिस्ट्री में पर्टिकुलर इन 3 चैप्टर का जो कि अपने आप में फिजिकल केमिस्ट्री से आते हैं, सॉल्यूशन, इलेक्ट्रो एंड केमिकल काइनेटिक्स न्यूमेरिकल बेस्ड है, न्यूमेरिकल डायरेक्टली वैल्यू बेस्ड होंगे इफ यू विल गो विद द जस्ट एंटायर पार्ट ऑफ द जस्ट टॉपिक्स ऑफ द चैप्टर्स. सो अच्छे से आप हर एक टॉपिक के वीडियो को अच्छे से देखें, अच्छे से पढ़ें और पेपर पेन वर्क जरूर करें, इसी विश्वास के साथ कि आपका प्यार हमेशा से मिलता है और मिलता रहेगा. फिर मुलाकात होगी एक नए टॉपिक के साथ में, तब तक के लिए शुक्रिया, धन्यवाद.